Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to go through your notes here, your college algebra notes on the review of functions. So what we're going to do here is we're going to talk a little bit about domain and ranges. So the term domain, all right, these are input values. That's true really of any type of function that we're looking at. Specifically with algebraic functions, those are going to be x values, right? Range are the output values of any function. When you're talking about algebraic types of functions here, those are going to be y values. All right. Next part of your notes, it says if you have a function, then for every value of, there is one value of. All right. So if you have a function, then for every value of x, there is one value for y. There's a test for this when you have a graph in front of you called the vertical line test. Right. Anytime a graph maybe something like this, if you can draw a vertical line through it and have it touch twice here and here, it fails the vertical line test and it's not considered a function. Next part of the notes, it says if you have a one-to-one equation, then for every value of, there is one value of. Right? So the answer's there. If something is one-to-one, then for every value of y, there is one value of x. Right? The test for this is called the horizontal line test. If you can draw a horizontal line through it and it touches twice, then it's not one-to-one. An example of something that fails the horizontal line test. Well, parabolas. Those are the examples that come to mind. See, if I draw a horizontal line there, that touches twice, so that thing's not one-to-one. All right, next piece of the notes here. I'm going to get rid of this stuff. All right. So let's see. Draw a picture to fit the given criteria. So the part where it says function here. Okay, there's an axis here. Oh, I'm just going to draw anything that's a function. Here's an example of something that is a function. You'll notice that I can draw a vertical line. All right, anywhere along here, notice that this line only touches once, so this thing is a function. Okay. Next one, it says something that's one-to-one. All right, well, here's an example of an equation that's one-to-one, you know, a horizontal parabola, right? That thing is one-to-one because if I pick any, don't need this, if I pick any y value, say this one right here, right, here's my y value, there is exactly one x value for it. So this thing is one-to-one. It's not a function, but it is one-to-one. And again, you'll notice that if I do the horizontal line test, right, it touches only once. Notice that this one fails the vertical line test though, right? So it touches here and here, that thing's not a function. All right, one that's both. Well, here's a graph of, this graph right here is a sketch of y equals x cubed, just a quick sketch. That thing's both, and again, you'll notice that it passes the vertical line test, so it is a function. It passes the horizontal line test, so it is a one-to-one function, and therefore has an what's called a inverse. All right, and I'm sure that will probably come later on in the notes. I need a little more room here. I'm going to move this stuff over. All right, something that is neither a function or one-to-one. Oops. Well, here's a quick sketch here. Circles or ellipses, doesn't matter which. Here's something that fails both the vertical line test and the horizontal line test. So here it is failing the horizontal line test. Here it is failing the vertical line test. This graph is not a function and it's not one-to-one. All right, next part where it says using technology to determine the domain of the function, make a quick sketch, use algebra to show exclusions, try to find patterns. All right, well, I don't have any. I'm not going to bother with the calculator or the technology. I don't have one handy. So number one here, where it says f of x is equal to minus 2x plus 1. All right, as far as domains are concerned, domains are input values or x values. My recommendation when you're talking about domains of algebraic functions is start with the assumption of all real numbers unless you can show otherwise. Now here's some things that will show up where, like when I say otherwise, here's the things to look out for. Division by 0 is not allowed in the real number system. So anything that looks, you know, maybe like 3 over x minus 4, whoops, anything that looks like this, all right, you would have to throw out x equals 4, because x equals 4 would give you a division by 0. So the domain of this function is all real numbers except 4. So you could say, the quick way to say that is maybe x cannot equal 4. Another thing that shows up is square roots of negative numbers. So like y equals square root of x. And by the way, not just square roots, but fourth root, sixth root, any even root. If you're going to take an even root, then this thing needs to be positive. So the domain of this function right here is x has to be greater than or equal to 0. Right? We would throw out any negative values for x. So generally speaking, when you're finding domains, start with kind of an all real numbers assumption, and then look for algebraic problems. And these are the two types of problems that will occur. So as we look over here, there is no fraction, so there's no division by zeros possible, and there's no radicals. So the domain of this function is all real numbers. Okay, range. Usually with range, what you want to do is get a graph of the thing and have a look at it. And I'm just going to do a quick sketch here. This is a line, slope -2, intercept of 1. So if I just do a real quick sketch, it's looking something like this. You'll notice that if we go this way infinitely far, this thing's going this way infinitely. Right? And notice if we go to infinity this way, the graph is going to, actually it's going to minus infinity in this direction. So the range of this function is all real numbers. All right, so domain is all reals, range is all reals. Let's get rid of that. Next one on the list is f of x equals, 3x squared plus 1. All right, so let's talk domains. And again, start by the assumption of all real numbers unless you can show otherwise. There's no division by zeros possible, and there's no square roots. So the domain of this function is all real numbers. There's nothing to worry about. Next, look at a graph. Now, if you're good at graphing these, you can do it in your head, and that's fine, and sketch it. Or, the directions here are using technology. So the implication here is that you can graph this using a calculator. If you do that, what you should find here is that this thing's parabolic, opens up, goes through the point 0, 1. The vertex is right there. Okay, so domain is all reals. Range. Now you notice there's no y values down here. So the range of this function is y has to be greater than or equal to this value, 1. There's different ways to state domains and ranges. I'm just going to use symbols like this. So the range of this function is from y equals 0 to plus infinity. That one is done. All right, let's get rid of this. Next one on the list is f of x equals 6 over x minus 5. All right, so let's talk domain. Start by the assumption of all real numbers, unless you can show otherwise. Now, this one's got a division here. If x were equal to 5, we'd have a division by 0. So x equals 5 is not allowed. So we're going to say all real numbers except x cannot equal 5. So all real numbers except 5. We could also say this another way. There's lots of different ways to say it. We could say that, let's see, x has to be greater than 5, or x has to be less than 5, right? X greater than 5, x less than 5. That would cover everything as well. Notice no equality on these inequalities here, because that's not allowed. All right, range. So you typically do that with a graph. I don't have a calculator in front of me, so this will take me just a few seconds here to get this thing sketched. All right, so this thing right here, you'll notice that x equals 5 is not allowed. That yields what's called a vertical asymptote. So I'm going to come over here to x equals 5 and put in the asymptote. Asymptotes are wonderful graphing aids. So I'm going to go ahead and we're going to make that a green asymptote. So now, algebraically, when functions approach asymptotes, they typically either go to plus infinity or minus infinity. This one, give me a moment here to kind of think about what this thing looks like. Well, I'm going to start with this. If I put 0 in, this would be gone, and y is going to equal minus 6/5. So I'm just going to put that in here. There's a point on here. 0 minus 6/5. And I'm going to take note that as x approaches 5 from the left, these would be numbers like 4.9, 4.99, 4.999. This ratio becomes infinitely large. Try it with your calculator. Put in x equals 4.9999 right here, and you're going to get a really, really large negative number out of that. So what that means is, as we're approaching the asymptote, y is going to minus infinity in this direction. As x gets really, really large, this ratio gets really, really small. So this line, the x-axis, is what's called a horizontal asymptote. So this thing does this. If I look at a number to the right, I'm going to put in a value maybe of 6 here. 6 minus 5 is 1. 6 over, I'm sorry, let's see, 6 minus 5 is 1, and then 6 over 1 is 6. So this thing goes through the point 6, 1. So 6, 1. Okay. Now what you have to imagine is, if I imagine now kind of approaching this asymptote, if you put a value in here like 5.1, 5.01, 5.0001, if you run this through your calculator, you're going to get a really, really, really large number. And that means that as we approach the asymptote, the function is getting closer to vertical like this. And then if x gets really large, like in your calculator, try putting in x equals, say, 100 into this. Right? You're going to get a very, very, very small number. That means when x gets large, when we go to the right, the function gets very small. So we're approaching this asymptote here. Okay, so here's a sketch of this function. Could have did it faster with a calculator, but I don't have one in my office here. So there's a sketch of this animal. Now I'm going to take note of the range. You notice we're going to plus infinity in this direction, right? If you look at what's happening here. We're going to minus infinity in this direction. If you look at what's happening here. If you look at this, kind of investigate, as we approach this horizontal asymptote here, we're getting closer and closer and closer and closer and closer. Basically, we're getting infinitely close here and on the right-hand side. So there's really only one value we have to throw out for our range. So our range, one way to say it is this: y cannot equal 0. It's all real numbers except 0. Another way to express that, how about y is greater than 0 or y is less than 0? But we wouldn't put equality on there. So either of these are kind of acceptable, or we can, basically say all real numbers except 0. That's how I would state it. So there's the range of that function. Let me do a couple more here because this video is getting kind of long. Get rid of this. All right, next one. Okay, is f of x equals square root of 4 minus x. All right, let's talk domains. So again, typically when you're talking domains, you assume all real numbers unless you can show otherwise. Now, if we're going to square root something, the something has to be positive. So 4 minus x has to be greater than or equal to 0. This is actually okay here because if square root of 0 is 0, so the equality gets to stay. Then if we just add the x to the right, x has to be greater than or equal to, whoops, I'm sorry. I had that backwards. If we add this to the right, this is now going to read 4 is greater than or equal to x. So x has to be less than or equal to 4. Either of these is an acceptable way to express the domain. And just to check to make sure it's working, let's see, x less than 4. Well, 3 should work. Put a 3 here. 4 minus 3 is 1. Square root of 1 is 1. It's good. All right, so there's our domain. Range. Sketch it. All right, so let's see. I'm going to sketch this, taking note of my domain. This thing is not defined for values like x equals 5. So I'm going to start here at 4. If you put 4 in, you get 0. I'm going to take note that if you put 0 in here, square root of 4 is 2, so it goes through the point 0, 2. This graph looks something like this. Gets bigger forever to the left. So our range, I'm taking note that y can be 0 or anything bigger than that. So y has to be greater than or equal to 0. There's the range of that function. All right, last one here. Then I'm going to call it a day on this video. Whoops. Get rid of this. Clear. Oops. Oh, that's okay. All right, so the very last one is f of x equals 1 over square root x plus 5. All right, so let's talk domains. All right, this one's got a couple things going on here. One, it's got a division by 0, can't allow that. So domain-wise, we'll start with this. X cannot equal 0, because otherwise we'd have a division by 0. Furthermore, we have a square root. So if you're going to square root something, this has to be positive. So x has to be greater than, x plus 5 has to be greater than 0. Subtracting this, so we're going to have x has to be greater than minus 5. Okay, so this one, and I just want to make sure I did this right. We're going to do this. This has to be positive, so it's got to be greater than or equal to 0. Had this not been in the bottom, we could have put an equality here, but it is in the bottom, so I'm going to leave that with strictly greater than. Whoops, okay. Now I see why I was a little bit confused. I go back and talk about that domain again. About this part of it. All right, division by 0 here. I got to go back and redo the division by 0. It's not x that can't be 0, it's x plus 5 can't be 0. So let me put x plus 5 here, cannot equal 0, and we'll move this over here. So x cannot equal negative 5. There we go. Now this is making more sense to me. Okay, so we can't allow x to be minus 5 because we'd have a division by 0, and then square root of this thing needs to be positive, so I'll put x has to be greater than 0. Now normally you would have an equality here. If this thing was up top, you could put the equality, but since it's in the bottom, I'm going to leave that off. All right, so the domain of this function is here basically. X has to be greater than minus 5. Right? Minus 4 should be fine. You know, if you put a minus 4 in, plus 1 is 1, square root of 1 is 1, we're cool there. You can put 10 in, 15, 20, any value for x here. Greater than minus 5 will be good. Okay, range. Let's start talking about that. Okay, now I'm going to have to pause this for just a moment and see who's on the phone. Okay, I'm back. All right, now I got to get back into thinking about what we were doing here. I believe we were talking about the range of this function right here. Okay, so I don't have a graphing calculator with me. I'm going to have to sketch this by hand here, so give me a minute here. Let's see, negative 5. I'm going to put that right here. That's going to give us a division by 0, so that's going to be a vertical asymptote. I like green asymptotes. So I know this guy here is a vertical asymptote. This function is only defined to the right, and I'm just going to imagine a value like negative 4.9999999 in here. You're going to get a really big value for y. Okay, so this is doing something like this. And if I put 0 in, this is going to be 1 over root 5. Suffice to say that's going to be some positive value. It's not even important what. If x gets really, really big, this is going to go to 0, so this is going to be a horizontal asymptote. All right, so a graph of this function should look something like this. Hopefully I did that right. You can check it with your graphing calculator. And the range of this function, you'll notice that we have all positive y values, and it's never going to cross the axis here because x can get, you know, really, 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 really big. That's still not going to be 0. So the range of this function is y has to be greater than 0. No equality here because it's not actually going to cross the axis. Like if I were to set this equal to 0, this equation has no solution to it. There's no value of x that gives identically 0 on the right. All right, so there's that page of notes. That took a lot longer than I thought at 19 minutes. I'm going to stop that video right there. Hope that this helps. Have a great day.